Okay, today we're talking about parametrics, reviewing for a big test, and the first one on the board here is a parametric. It's got three variables, x, y, and t, and only two of those that actually go on the graph. Here's x, here's y. If I were to ask you to graph this, your best friend would be this txy chart, and the logical thing to start with for t is what? 0. When I stick in 0, I put in a 0 here and here, and it's really easy. It's 8 and negative 7. Raise your hand if you had 0, 8, negative 7. Awesome. And then I'm going to call on a group after I give you a little work time here to give me the next few points. Pause it. So what did you guys say for the next spot on the TXY chart? Hold on. What was T, though? Okay, for 1, you got 10, and you got negative 5. Raise your hand if you guys had the same thing. And the last one? 2, I'm assuming, with 12 and negative 3. Now, did those 3 points that you graphed line up with each other? All right. Was there another point? Oh, there is another point. Thank you. There's 3 goes in, and you get, can somebody tell me that one? What did you guys get? 14 negative what? 1? Okay, good. All right. Now, if I go over 8 and down 7, and I go over 10 and down 5, and I go over 12 and down 3, and I go over 3, wait a minute, no, over 14 and down 1, there, they're all lining up, yay. And does this go on forever like this? No, this is a really important thing. Not only does it end, it's directional. Do you get what I'm saying? It didn't just start and end and have a line in between. It had a direction. How do you indicate that on the graph? With a little arrow. I know I didn't tell you this before. I'm telling you now. I wouldn't be out like, oh, you get the whole thing wrong if you forget this. But they are directional, and that makes a big difference. So where did it start? Well, when t equals 0 is where it started. So that was this point, which was this point, is where it started. So then if you put a little thing along the way that goes like that, that would work. If you labeled it like this instead and said t equals 0, I'd be fine with that. But if you just had the dots and you didn't ever say anything about the direction, or labeling some points like t equals 0 would be a logical starting point, t equals 3 was the ending point, you don't have to label every point in between. But do some labeling of t or putting an arrow on it. Otherwise, it doesn't tell me which way it's going. All right. Then we change this from parametric to function form by solving this for x. And so you hopefully did x minus 8 over 2 equals t. And the other one, I hope you did y plus 7 over 2 equaled t. And then you'd set them equal to each other. X minus 8 over 2 equals y plus 7 over 2. You multiply both sides by 2, which works out really nice because it just cancels those. And I have y minus 8, or sorry, x minus 8 equals y. Is that a plus 7? Okay, thank you. And then I'm going to subtract 7 from both sides. And did you get y equals x? And if I add 7, minus 1? Is that right? So how many x minus? Subtract 7. What did I do wrong? I'm sorry. I added 7. Okay, so I need to subtract 7. There we go. Minus 15. There we go. And if you think about that, it makes some sense because I need this to match up with this. And this has a y-intercept way down, if I extend my page out here, way down here somewhere, which would be like where? Negative 15 maybe? All right, so this needed to match up with this graph here. But alone, like that, like I guarantee you at least one group did, would be wrong. Why? Because that is a line that goes forever in both directions. And we need it to stop. How do we make this thing stop and only go from one spot to another? We look at our TXY chart and say, used to be limited between 0 and 3 was t. Okay, and now we're going to say, okay, at t equals 0, x was 8, so that means it's going to go from x being, that's like the x-axis, right, 8, to x being, what was the highest it was? 14. So x had to be between 8 and 14. How many of you actually included the x between 8 and 14 thing? Okay. didn't catch that. You really needed to catch that. Because they need a domain. Otherwise, that line will go forever. And you only have x's and y's, you always choose x for your domain. All right. Now we need to be able to go the other way. Now, we briefly touched on this yesterday. We got to touch it a little longer today to make sure that we get this. If you have y equals x squared plus 4, actually, we did something exactly like that yesterday. Let's do x squared minus 2. Do you get that's a parabola that's been shifted down a couple? You with me so far? Okay. Then, if I have to make this a parametric, I got to tell you just some part of this line. So I'm going to say from the very bottom of it, like right here, to, let's go put in x equals 2. When you put in x equals 2, you would get 2 squared is 4 minus 2 is 2. So then you get 2 comma 2, which is like right there. 2 comma 2, and this is like 0 comma negative 2. And so there, I've just got a little part of my parabola that I want to make a parametric equation for. And does it have direction? Oh, yes, they always have direction. You usually go from left to right. I'm going to tell you it goes from here to there by putting a little arrow on it, saying it's going in that direction. Now, you should be able to make me a parametric for this. First thing you hopefully think is, okay, parametrics always look like this. I got an x equation, I got a y equation, and then I got a limit of t between something and something. Or it could just be t is greater than 5 or something like that. But I need some kind of domain. All right, and you already have a y equals equation. So there's the hard way and the easy way. Hard way is if I tell you, like, okay, I want your x equation to be like 6x or 6t plus 7. Then you'd have to put this in where x is, and it would be really yicky. What's the easy way? You can pick whatever you want x to be. So make x equal to t. And if x equals t, it's really easy to write the y equation because you've already got it here. You just have to make a little adjustment to it. And then remember, you won't have this all done until you have your t limit, which you have to figure out based on what the limit was in the first place. All right, I'm going to give you a moment to put this together and see if you can write me a equation for this parametric. Pause while you give this a shot. So, hopefully, you remembered you just said x equal to t like this, because, by the way, what if Mr. Server was mean on the test and said, by the way, you need to say x equals 8t. It's not that hard. Just put in wherever x is, you'd put it in 8t, and you'd have to, you know, do a little adjusting when it came to your points and stuff. But for right now, let's just stick in x equals t, because if you get a choice, that's the easy way. Okay, and this will be a parametric, which is all you really need, is a parametric that will recreate this. All right, so then y equals, and let's actually try putting in t where the x is, and oh, it's just t squared minus 2. Cool. That's it, except I now have to tell where t is going to go from. Can I just take and say, well, I'm just going to take from 0 to 2? Can you just say 0 to 2? Yes, you can. And I need you to understand why you can. Why is it that simple? Because x equals t. And the old limit was between 0 and 2 when it came to x. So the new limit must be between 0 and 2, because x is t. Okay, so 0 to 2. And just to clarify, it is inclusive, as in it's a dot that it touches, and so it should be or equal to. Now, I had those up there, but you'd have to be careful with that. You could lose a tiny little point reduction there. I wouldn't mark the whole thing wrong, but yeah, you should say or equal to if it's touching at that spot. If we really want to make the question tricky, we'd have an empty spot at the end there. And it'd be like up to 2, but not including 2. Okay. All right. So what else do you have to know? Well, you'd have to know how to actually put that in on the calculator in parametric mode. So let's actually graph this puppy that you just created, this guy right there. Put it in parametric mode on your calculator, because you have to graph some stuff. Okay, I'll pause while we pull out the graphing calcs. Okay, I'm putting this puppy in the calculators. My equation says x equals t, so I hit the X button, but a t shows up because it's smart like that. It knows that we're in parametric mode, and therefore it should use a t there. All right, next, y equals t squared. Again, I recommend using t and then not to the power of 2. It's much easier to hit the squared button right there. T squared, and then minus 2. And then I've pounded on this over and over again. You got to have a domain, but where does that actually go in? What button? Window. Hit the window button. And mine right now is going from 0 to 100. That would not be good. I want it from 0 to 2. And if you're going to pick a step, my advice is pick 0.1 as your step unless somebody tells you otherwise. Go by tenths. Because basically the smaller your steps are, the more accurate your graph looks. All right. Now, one more thing. This is just like the other window where it's telling you how small do you want x to be and how big do you want x to be. Basically, this will make our picture look either really big or really small. Do you get if I said I wanted to go from negative 100 to positive 100? It's going to be a teeny tiny little picture on there. All right, so I'm going to hit graph and see if I like the size. Yeah, that's good enough. I can see it. If I couldn't see it, I would just make my window numbers different. Warning, though, if you just hit zoom, a lot of kids want to zoom in. Let me just show you what would happen. If I said zoom in on that graph and then actually hit enter, it will zoom in. That's all good. But notice what happens here. I'm back on my window. It changes your, it didn't change my T-min and T-max, but it will change both your X-min and your X-max and your Y-min and your Y-max. And one other thing, a zoom 6, which a lot of people are used to as being kind of the standard zoom. You know what I'm talking about? Zoom 6. If I go to Z standard, zoom 6. That's a lot of people's favorite zoom. It's not like it's wrong. It's just, what did that just do to the window? It went from 0 to 2 pi. Do you get what I'm saying? Standard zoom brings you to a T-min of 0 and a max of 6.28. That's not what the problem said. It would be wrong if you graphed it that way. We were supposed to only go from 0 to 2. So now I can go back and look at what it really looks like. Oh, that is quite different. So be careful. If you use zoom 6, it will change your domain. Okay, now we've got to graph some more complicated things. Everybody type in, actually I want you to remember for just a moment, there's this connection between sine is a certain letter and cosine is a certain letter. Do you remember going back to the very beginning? What was sine again? Sine was y. What was cosine again? X. Tell me another time besides in circle trig where we ran into x being connected to cosine. There's a unit on this. We're doing a little bit of finals review right this second. There was a unit where x and cosine also got connected, and it wasn't the circle trig. It was something else. Can you read me one of those little equations? Hint, it has an r in it. X was what? R cosine theta. And what was y again? R sine theta. Okay. I'd like you to use those two in a parametric equation. So in other words, you got an x equation, you got a y equation. The only difference is that there's supposed to be a t somewhere. And r, let's just make r 1 to make life simple. You'll be on the unit circle. Where should the t be? There's only one logical place for the t. There can't be multiple variables in this thing or it won't be able to graph it, will it? So, all right, go ahead and put that in the calculator right now. Under parametrics. That's the only place we can put the variable. Cosine t. T must be the angle. We just said a second ago that the angle is being set to 0 to 2 pi, which kind of makes sense. And I made x cosine and I'm making y sine. Because there's just some symmetry there that we'd like to echo. Have it work out real nice. All right, here's how mine looks right now. It's like a weird little line. What didn't I change though? What affects your graphs a lot? The T, the window. How about we make this, oh, wait a minute, what is T? T's an angle. Let's go between 0 and pi. Instead of 0 and 2, let's go 0 and pi. And use the pi button. 0 to pi. And then graph it. Ooh, look at that! It went from 0 until it stopped at pi. If you were able to slow it down, you'd be able to see it better. It started over here, and it went to there. 0 to pi. All right, let's go to 3 pi over 2. You can do that? Yes, you can do that. How do you do 3 pi over 2? You figure it out. 3 pi over 2. Hint, parentheses would be smart. 3 pi in parentheses divided by 2. Now, because of the way this one happens to be set up, it would have worked if you forgot the parentheses. But don't forget the parentheses. And then I hit graph. Is that stopping where you would have expected it to? Look at that. What shape are we making? A circle. What if I want it to actually finish and be a whole circle? What do we got to do? 2 pi. Go to the window. Change 2 pi. 2 pi. Graph it. And it's a circle going to 2 pi. Now, if you're saying to yourself, Mr. Server, that looks more like ellipse shaped. It's just because of how the graph is naturally stretched on the screen. If we used zoom square right now, the only problem with it would be it would go automatically to 0 to 2 pi, but that's what we wanted. You know what I mean? If I go zoom square, Z5, it makes it look much more like a circle, doesn't it? Okay, but remember that resets your T, but it happened to be 0 to 2 pi. That's what we had anyway, so it didn't hurt. You know what I mean? All right. Okay. Did I just show you how to make a circle using parametrics? Did X go with cosine, and isn't that kind of logical? Because it always has. All right. Okay. Next. So many little things to know. We have gone from parametrics to functions. We've gone from functions to parametrics. We have graphed, and we just made a circle. How about if I ask you to graph something unusual? Why don't you try graphing for me what x equals 4 inverse sine of t would look like, along with y equals 3 cosine squared of t. Something unusual. Just see if you can put that all in the calculator. I'm going to pause for a second while you do. And by the way, nobody asked me an important question. To be able to finish this, you need to know something. The domain. Let's say t is between 0 and pi. Because if you don't tell people that, they can't know how the graph should finish. T, let's make it between 0 and pi. Pausing. I was asked a good question. Why didn't I put cosine by the x? You don't have to. If you just want a circle, you should. But, and especially because I'm using inverse sine, all bets are off. It's totally different. All right. So I'm going to put in 4. First, I'm going to clear it, actually. Now here I'm going to go 4. And then inverse sine of t. And then 3 cosine squared. How am I going to do that? I would just put it in parentheses. Now, does the 3 get squared when the cosine gets squared? It does not. 3 cosine of t, and then it needs to get squared after I end the parentheses here. There. And then I got to go to my window and make sure I only go from 0 to pi, 0 to pi, and now I hit graph. There it is in all its glory. Well, at least it'd be simple if it was a test to write down what the graph looks like. You know what I mean? It's not like having to create this complicated curvy thing. They are cooler looking when they're like that, but they're a lot harder to do on a test. All right. Yes, question? Or comment? And it probably just has to do with your window then. My window is going all kinds of strange numbers. How about if I use the same window as you? What window do you have? What's your t-step? I agree, 0.1 is a good choice. And then x-min? -10 to +10? All right, and then I'll go back to my graph. Let's see if mine looks the same as yours. Does that look the same? Okay, so go back to your y equals and make sure that you have the same 4 sign with -1 with t. All right, then one of us needs to reset our calculator if we're getting something else different than me. I have a feeling it might have to do with the parentheses and the nesting of the parentheses. So if you just squared the angle, it would be totally different than squaring the whole cosine of t squared. Okay. All right. If you're having issues on the test with your calculator, the one thing I will do for you is completely wipe your calculator for you if you want and get it back to factory new, because sometimes your calculator does get weird and it's like, what's going on? I can't get it to work right. I'll wipe it for you if necessary. Okay. So now this is the part where I want you to be able to work with a partner on this quiz for at least some of the time. And then the rest of it's your homework, and I'm going to post the key so you can check it. Okay? And then tomorrow's the test. All right. That's all I got for you for today.